No, right, this is on. I was just not on the right stream page. Okay, no, right, I'm just being confused because the... Right, no, hello, viewers across the world. We are, no, is this... Oh, that's not frozen, I'm just being confused on the screen. Yeah, okay. Where... I'm sorry, it's not the usual high quality production values. Let me just pop out the chat so I can keep an eye on it. And... nothing's working this morning. We're gonna get there. Well, I'm just waiting for people to join and kind of gather around children to do some live AQA Target Clear. Whoop. All right. What have we got? Oh yeah, let's turn on the turn off the no, not this one. Let's disable my AI extensions real quick that I totally don't use. No, I have reasons. And get to the ZigZag tasks. Now we have gone, I think, on the stream and out all the way to like 10. I think I may have skipped 9, but did it as a separate video. Anyway, so I have had suggestions. There was one that I was looking at, I got by email about 15, which is kind of serializing the game state to a... oh, hold on, I'm going to make things bigger for you. Or... yeah, that's a bit better. All right, I don't need the bottom one. But 11 and 19 are both about kind of the solving side of this and how to automate the solving. 11 is with a sort of brute force random method. 19 asks you to implement a proper solver. 17 is about accepting infix expression, which was the next one I was looking at in the Wikibooks task. Now the solvers are like this is not a realistic it's not realistic like section D from AQA task, but it's like a really super interesting one, especially the full solver when you need to kind of have a heuristic to find some solutions in some decent amount of time. The infix, I will need to make a video about it because I don't feel confident doing it cold, right? I can't do it in an hour like without just brushing up on how the conversions work and so on, but I will tackle it because I think this one may be a legit for a big 14 marks. Or even then, well, I guess, you know, like the logic here is like right, since there's no OOP in the skeleton code, then maybe there are some other, you know, the tasks are going to be about some other tricky concepts of the spec, and obviously like the actual implementation of expression conversion using lists and, well, actually queues and stacks data structures might be a realistic use case. But I'm not ready to do this one yet, I'll confess with you, so let's start with this one. Task 11. This questions introduce a new help mode feature to the game by suggesting targets which have been identified as possible through brute force. So all we want to do is just highlight them, right? We're not kind of showing, I don't know, they're not even telling us how to highlight them. I might reduce, oh yeah, we've start, right. We're not displaying which expression lead to that. They do not tell us about the strategy to find them. It's kind of brute force. So brute force is different combinations of operands and operators from the numbers allowed list. Get random suggestions, that's our new method, new function, where the brute force approach finds a possible expression, and the program should highlight the target with double stars. To reduce processing, should only use expressions involving 2 or 3 operands, and only up to 5 possible targets need to be identified in each turn. Up to 5 means 0, right? So it's like, if 5 possible targets are not found with a 30 attempts. So again, I don't really get that, right? Like 5 possible seems like what you need to meet, versus, because I would read this as like, you know, if you identify 5 target, give ups, or if you reach 30 attempts, give up, either way. But we can, this is probably just a tweak, and then we'll see how long it takes and whether we can, actually, interesting. It does not to display the actual expression, that was the key thing. It does not need to test every possible, obviously you don't, right? Because, yeah, especially with 30 attempts. So, so give the user the option and a suitable data structure to store those values. Fine. And then this one, the get random suggestion, is the new one where we're generating. So we're going to generate infix strings for clarity, and also because if you build the expression using postfix, using RPN, it's possible to generate expressions that the user cannot input because the current implementation of the game does not support brackets. So we're going to go via the infix expression as if it was a user input. So housekeeping, as always, copy this one. I've moved too fast. Yes, it is here. Excellent. Hello, SKE, long name. We are doing task 11, which was the next one, Z11. Right. Okay. Close this. Can everyone see okay? Pleasure to have helped. Suhaib says, I've watched some of your video for my mock and it really helped. Thank you. Cool. Well, I guess if they, because especially in the mocks, they use the ZigZag task, right? Obviously. Which, to be fair, I often repeat, are not as good as the AQA ones. However, they're probably the best you can get that I've got a mark scheme and come from the degree of approved thing. So I'm not surprised that people would use them in mocks. Well, sometimes you can use the last years or whatever for a mock, but let's see. Right, so in play game, we want, before enter an expression, like they say, give the player an option. I mean, it's just like in this weaselly, loose spec language. Gives the user an option to have to 5 target. Right, okay, so enter an expression, bracket, or help. And if user input I'm going to cast it to an upper is equal to help with some space, please. I don't know what I'm doing here. And then we're going to do stuff. No, the pass is not the comment. The do stuff is the comment. So at this stage, we're going to want to generate, well, not even generate, like generate and evaluate the expressions. Find finalizable targets and display. See, they don't tell you, right? So we were talking about I put this video about the mark scheme. There's oh yeah, no, actually, sorry. Okay, they do tell you we did display states and display targets method. Finalizable targets and then like another call to display state. Okay, so let's focus on get random suggestions, and those are the ZigZag questions which are available. They're not publicly available as far as I know, because you kind of pay a little bit of money to get them. But you know, if you ask around, I'm sure someone. That's how I got those, right? By the way, the students sent it to me. Right, so let's decompose this, right? Let's worry about finding the targets separately. Just assuming we've got highlightable targets or highlighted targets. The point is that this needs to, okay, here. So every turn, right? Every click of the game loop, I have my highlighted targets. No, sorry, this coding style target screen is just. Oh, if I change the screen, I was going to change the camera. This is the problem. Okay, that's why we're there. Highlighted targets. So I'm just going to store the indices, so like where they are on the list of those, which at the moment I've got none. We display the state. We need to pass highlighted targets to display state. Actually, it's going to be targets in the plural. And then in display state, we are going to need to accept it as an argument. Is this, that's just too long. Highlighted target. No, yeah, highlighted targets with an S. And we then pass this on straight to display targets, which in turn needs to accept it. And now this is where I did that for the frozen ones, right? You can, so instead of printing, we're going to generate a string. Right, so at the moment we're choosing whether to print an empty a one or a number, the target t for t in targets, right? But instead of print, I'm going to want to say, so for t in targets, it doesn't really matter, because like we're going to have, it's going to be defined in every branch of the code, but you don't need to initialize it as above. S for strings, capital S if you're precious. So in that case, the string is just this, and else the string is, I'm going to comment at the prints for now. Else the string is t. Well, it's t cast to a string, because print, right, this is what happens here. We want to build a string by concatenation, so let's take the value of it. And so as this does, then all we need to do is just print whatever that thing here. The end equal nothing means don't put a blank line or a space or whatever at the end, so just kind of print continuously. And equal, and then it does 2 blank lines here by print. So this keeps the function as it was, but now I end up here with just an S that I can play around. So particularly I can start adding stars around it, right? And then I'm simply going to do if, so this is why instead of iterating over the targets, I will need to have an explicit iterator. So for I in range length of targets, then t, we don't know what t is, right? So that becomes, well, all of the t's, actually, so this one and this one, well, no, not the lowercase t, obviously. Okay, this become targets at index I, here too, bracket I, which means, all right, now we're back in business. So now I've got the I, and if I have S, they have the nothing or the target number as a string, and then if the target number, so if the index is in the highlighted targets, so that should really be highlighted targets indexed, targets indices, but whatever, right? So if the index, right, so if we're moving on to that, and if it's when the target we decided to highlight, S becomes equal to a star plus S plus a star. Then which I got, whoa. Yeah, all streams are posted afterwards, they just stay on YouTube, right? Well, unless like Craig and Dave asked me to take it down because I'm disclosing the ZigZag task, which obviously are not free and not freely available. But information should be free. If we learn anything from the tech bros that are ripping out all of copyrighted human text to train AI models, is that information should be free. Don't take this seriously. Okay, so now we turn our printing into the building of a string, which may or may not contain here. Will never wrap, well, unless I've really messed up, well, unless I, in the future, and what we're going to do next, I mess up seriously, we should never obviously highlight a blank one, right? Because it's not a solvable one. But if, whatever, we could have run this in here. We could have put it, yeah, if you want to be precious, actually, yeah, let's be consistent. So in here, right, we would have put, yeah, right, and I need to tab this a bit, no, not here. Right, so and this, okay, regression, right, so like this will work as it used to, because all I've done is sort of change the way I print the string, but that, my point is that you encourage to check, so 3 minus 2, what was it, like, oh yeah, 8 plus 3 minus 2. Everything still works. This is important to check this at regular intervals. So all I've done is refactor this so that it's able to accept highlighted targets and start arbitrarily kind of, putting stars around the ones I've identified as solvable. But now comes the trickier part, which is actually, so they tell you about get random suggestions. It's unclear whether this is to operate as described. So this could be get random suggestions of expressions to evaluate, and then you don't know whether they're going to be evaluate to a target or not. Or this could be get random suggestions of targets. So my question here is, in that big thing I said, right, so Yes, so in this case, right, do you have a call to display state? We can do this now. Find highlightable targets is going to be something like highlighted targets becomes equal to whatever function returns a list of the ones I've identified as solvable. My question is, does get random suggestion is about, that should be that, right? We should put everything into that, but there will be within that, yeah, fine. Let's use this because we keep it out of play game. Get random suggestions. Now, this needs to know everything about the game. Well, it definitely needs to know about targets and numbers allowed. Right, I don't think it needs to know about anything else. The training game doesn't affect it. We're all good. Okay, let's just put it right here. Def, this is get random suggestions. Okay. And it takes targets and numbers allowed. Targets, numbers allowed. I can remove the pass, obviously. Targets and numbers allowed. Fine. Okay, now this should return a list of indices of solvable. So highlighted targets, I think we've gone for, right? Oh, it doesn't complete because it's outside of the scope, so we can call it whatever we want, right? But like just for the sake of consistency, it's highlighted targets. Highlighted targets indices, really, but we start with the empty list because we get nothing, right? And then I can do 4. So when you want to combine, this is an interesting problem, right? Because like we have 2, so we want to loop. Okay. Until we've tried 30 attempts, like 30 expressions. Or we have highlighted 5 targets. So that's a bit of a problem. Well, you could do a big while and keep your counter yourself, but in that instance, I think the counter is easier to. I'll show you what I'm going to do here, right? I'm going to go with a 4 with nothing because I don't need the iterator. I just want to repeat something 30 times at most. I might bail out early if I've got 5 targets. For nothing in range 30 to repeat it 30 times. And watch out here. Immediately what I'm doing here is if, as I come into this loop, if the length of okay, so when they say 5 targets, do they mean like 5 different numbers? As in like 5 targets of an expression, or 5 targets as in targets on the carousel of shooting gallery, meaning 5 locations in the targets list? Because one expression that I try might yield more than one of these. In fact, I might actually, if I wanted to be clever, I would try to look at the ones that feature more than once in the targets list, but whatever. Anyway, so let's assume that it's like 5 positions in the target list, right? So if on my first attempt at generating an expression, I happen to kind of find a target number that's like 4 times in the list, I'm already kind of 80% of the way there. So because that's going to be one expression tried, but I'm going to have like 4 indices in my highlighted targets list. So if the length of highlighted targets is equal or greater, because it could be greater, right? Because it's like this, by the way. Because we could have 4 and then like find another one that gives us 3 more because they can appear multiple times. So if that's larger, I'm just gonna break or continue. I'm breaking, right? So like I'm just getting out of the loop. We've done our job before we reach the range of 50. That's my kind of check. So this will take care. This is this hybrid condition, right? When you get like, okay, so you get something that's definite, like up to a maximum, but also you might bail out earlier. That's the better way to do it, I think. Although you can have a combine while and, you know, and have your own iterator and like increment it yourself, click, 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 but whatever. Now, when it comes to the first part, I think I need expressions I've already tried. So, because I might accidentally regenerate, right, hold on. Okay, so brute force, the issue with brute force, did I ever, I might just like run it quickly to show you what I mean. That's probably not, that really doesn't, let me run the original, actually, okay, let's say I've got the training game and I want to brute force, whatever they mean by that, all of the expression in it. So 2 to 3 operand. So I'm going to start and, you know, any operator. So I'm going to start with 2 plus 3, 2 minus 3, 2 times 3, 2 divided by 3, right? And then 2 plus 2, 2 minus 2, right? Some kind of, this is the way of brute forcing it if you want to try them all. But because we know we don't want to try them all, and because if we pick kind of the wrong starting number, having all of the expressions we try feature the same operand, the same number available, is a problem because we might kind of churn for a while without finding anything. So what I'm going to do is I'm going to select the numbers and the operators randomly, bearing in mind that the possibility space is humongous, right? That's this kind of combinatorial statistics, combinatorials really, which is, you know, kind of something about the factorial, right? So let's say you want, how many two operands expression can you build out of those 5 numbers? It's 5. There's 5 ways of picking the first number, and then out of that, because you can't repeat numbers, another 4, so that's 20. So you can work this as like how many unique ordered combinations of however many elements of a larger set. There's a calculation for this, and because it uses factorials, it kind of blows up really quickly. And for the operators, right? Well, because we're only limiting ourselves at like 2 to 3, there's only 1 to 2, but even the 2, that's like, because we don't have the constraint of not repeating operators, like we have a constraint that we can't repeat operands. Even with 4, it's 4 times 4, there's just 16 of them. Right, like you could pick the same 2 numbers and still burn like more than half of your 30 attempts by trying the 16, because you need 3 to do 16, right? But anyway, so I'm choosing at random. Well, I'll let the code draw some random ones. And so I need, where's my stuff? Oh, I'm in the wrong file, obviously. I need to figure out what I've already tried, right? So I don't kind of accidentally do the thing. So here I'm going to say, so we've done this as the if with a break, and then I'm going to say the infix. The infix expression becomes equal to get new random expression. I'm only using numbers allowed for this one because I don't need the targets, right? So but I can't have it as a new function. It has to have a new function, right? So the infix expression is equal to, okay, so let's try generating an infix expression. I would say this is there's a random pick, right? There is a random pick. Is it pick? No, choice. So Python, right, import random, and okay, so L is equal to 1, 2, 3, maybe 4, let's go crazy. And if I do random dot choice inside L, it picks an element of L at random, right? So if I want to select, I'm gonna have the operators. It annoys me, but we should really have some kind of global or higher level thing, especially if one day you want to support exponents and whatever. But for the time being, we're going to need to have another copy of this set of characters. Those are my operators. So infix expression. So I need to decide whether to make it 2 or 3. we've imported random already. Yeah, because this is a way kind of create thing. So okay, the infix expression is equal to random dot choice of ooh. So how do I ensure? Now I'm trying to think, how do I ensure that I'm not reusing operand numbers, right? Because you'd think, well, is it not already in the expression? You'd think, but clearly you need to be able to support times when there's kind of 2 times 2. Fine, we're going to take a copy of the list. Fine, so let's call it operands is equal to a list of the available numbers, right? I want to take a copy because I want to start removing stuff from it, like we do when we populate the numbers and see which ones have been used. And for this, I need the copy of the list. Otherwise, I'm going to make change to this straight because this is passed by reference. So the code only gets the pointer and goes and changes the data in the memory and it's used by a function. So I'm making available numbers allowed, not even using the right into a list. That takes a copy of it. I'm fine. So I need to kind of have something a bit more fancy than this, right? So so this is going to be opt1 is equal to do you know what? No, I'm going to shuffle it, right? Instead of using choice, I'm going to shuffle it and then pop the first one. Pop, just call pop, which pops the last one, right? But it doesn't really matter which one it pops, but it removes from the list. So the next time I kind of pick, it will, sorry, I won't pick because it's already shuffled, I just pop, right? So instead of kind of picking a card at random, like pick any card, picking any card, instead of fanning the deck and picking at random, I'm shuffling the deck and I'm dealing the cards one by one. Much simpler. So, okay, does random shuffle, does this in place, or does it, yes, it does it in place. It doesn't return anything, it just kind of does it. So let's shuffle operands, shuffle, random, the ZigZag tasks are not on Wikibooks. In fact, the Wikibooks task, people write to the stuff in Wikibooks from September when the stuff is published, but ZigZag only publish their task around January, and in fact you'll find, well, to be some are kind of obvious if you, and they kind of specify them much better, but you can see how the kind of general crowdsourcing of the brainstorming of Wikibooks ends up in ZigZag. I'd be curious to see whether there is something from ZigZag that wasn't in Wikibooks at all. Right, so random shuffle to shuffle the list of operands. So then my infix, what did I call it last time? Like expression, infix expression? Infix expression. I don't think Wikibooks are better than ZigZag. I don't know, like Wikibooks, they just put a question without much specification, and then someone will post an answer in code. So it doesn't really tell you much about how to, better specification as to what this is meant to do, or how to decompose it in tasks, and then like what to watch for and how you will be marked, because you just get like the code rather than an explanation or a mark scheme. But then equally, even ZigZag, who kind of try and decompose and specify and give you a mark scheme, as we've seen, that's kind of still not, I think they serve a different purpose. Like the Wikibooks tasks are more than enough to just like have something to do to familiarize yourself with the code. It's just that if you're operating kind of in a vacuum and you want to kind of really think so I think those are really helpful to teachers, because you can set them to the students and then you get a mark scheme that allows you to see what's there and there. And it's kind of, it comes from professional. I think that there's a sort of cachet of quality, hopefully. Right, the infix expression is going to be, which is nothing at the moment, is going to be operands pop bracket bracket. So I call operand swap that just picks the first one of my shuffle list, plus random choice of operator, plus operand. This is gonna need a lot of debugging, and then I want like maybe 50-50 chance, let's say. So if random is smaller than 2.5, we also add another one. So infix expression becomes equal to, I think I can do plus equal here. On strings, I'm feeling lucky. All right, so plus equal, so I don't need to do the expression. So we're gonna add, so flip a coin, and then we get a 50-50 chance of actually making it a free numbers or free operands expression, which means you just add another operator, which is random choice. Well, we just add this, right? Kind of another operator and another operand. Okay, and that's the infix expression. Now we have tried it. So we're gonna append it to tried, because tried doesn't mean it succeeded. It just means we don't want to try it again. Okay, now is it a valid one? Ooh. Okay, so we could convert to RPN. Right, yeah, we can just convert to RPN and we get the RPN expression and pass it to, yeah, there's the problem. No, I can just evaluate RPN, right? I don't have to actually go through the whole thing, but here, this way it finds them. So there's a question like, how do I find something in the list in Python by value, which, is it find? Is it a locate? There's probably a native list function, but you can just kind of go, we can do it by hand, right? So is there a valid one? Let's find out. Postfix expression. So is equal to convert to RPN the infix. Now we know it's going to be a valid one, we don't have to worry about this, and we know it's only using available numbers. It's kind of like, it meets the first set of criteria of the that we expect of what the player inputs. Okay, we've got it converted to RPN, and then we can just evaluate this. Okay, so possible target result. Right. I get a feeling I want to test it up until here. And wait. No. Okay, so this is the thing. So before I do this, we need to check that we haven't tried it. So let's go with infix expression is equal to the empty string initially, right? Why not? And then while no, because it's not going to go into it if I don't. This is annoying. I need to do it once. Fine, I need to do it once, and then okay, this one I could use a boolean or whatever, but fine. So we've built the first one, and then while the fixed expression we've just built is in the ones we've tried, we're going to do this again. Now this doesn't count, right? Like this is 30 evaluations, but like the chances of collisions are marginal, especially since we kind of not going to fill this with many. Well, we'll find out because we might try the whole bunch. Well, I don't think this is going to be a problem performance-wise. I think this is a problem indent-wise because that's meant to be here. Right, so we first generated the infix expression with a 50-50 chance of making it a free operand's expression, and then we check. We're going to repeat this as long as we get something that is, what's wrong here? What? Okay. Right. So we now have a unique new expression to try. Try question mark, and then we evaluate the RPN of it. And am I gonna put an ugly print to just, yeah? Ah, fine. I'm gonna have to write L. Yeah, L. Index, I think it's just right. So what if I get something? Okay, so if I append L, append another 4. Now L is this. Okay, L dot index 4. It gives us the index of the first. I mean, I'm not too precious about it, right? Like if the player only sees the first one being highlighted as with stars, it's not presumably a massive deal, but kind of want to get that right. Okay, you're not going to be allowed to do this during the exam, but let's just real quick. Google list index of list element by value Python. I'm sure there's stuff that you can pass Python. Yeah, I know, I get that, but can I get them all? So value error if it's not there. Oh, if it's a value error. All right, okay, fine. Well, I can use an in. Yes. Yes, and that's start and stop. What does that do? Right, so if you want to restrict it, finding all occurrences, thank you. Right, okay, it's just a list comprehension. Fair enough. And what do you enumerate it? I for I, N for N? Oh, so it's, yeah. Oh, sorry, I for IN in enumerate. So enumerators allows us to give us indices and values. Yeah, fine. I feel bad. You know what? I would have kind of done it by hand, but whatever, right? So I'm just going to use index. Let's say, because you will know about index. I don't know if kind of list comprehensions, I've talked about it, you may know about it, but like, I think, I don't know if it's a new project. Who knows? Right, let's just... If result not in targets, continue to stop getting the, I mean, I could have done that differently, but it's easier to kind of say, all right, if it's not in target, I know what I'm doing, I'm not even worrying. Like, let's know, wait, let's do it properly. Okay, if result in targets, right, because you've seen that if I call index, it's going to give me it's going to actually throw an exception. So I hate to actually do control throw by try blocks and except. I don't know, but in that instance, it's not appropriate, I don't think. So the result is in target, then we are going to, do we append? Yes, right? So the highlighted targets, yeah, it's cool. Highlighted targets, we're going to append hi. No, we append to them the the targets index of result. And I mean, and then at the, I guess at the very end, once you're out of the loop, you just want to return hi. There's no way this will work, but Hey, we'll learn a lot by trial and error. The spirit of tinkering and excitement. Well, I'm not going to even bring it in debug mode. I'm confident, right? Help. Ooh. All right, so dock you a point and then don't. What did I mess up here? Maybe I kind of went. Okay, so if it's input, we highlight the targets and we display state. I literally, what? We're getting to the fun part. Okay, I've got a breakpoint here, which means the code is going to stop when I hit this line, just to check that I'm actually going into this test when I type help. Did I type help with an exclamation mark or something, or no? Well, this is fun. Oh, of course, if it's okay, if it's upper, obviously I'm typing it in lowercase anyway, but just I could probably even do like starts with H, right? So if you misspell it, yeah, whatever. It's not like we're accepting a whole bunch of different commands on this line. Okay, back here, right, help. Now, the moment it was printing, okay, so I've got some type. Of course, I need to pop. Yeah, those are integers in there, not strings. So I reckon that. Well, fine. You know what? Like every time there's an operand pump, we gonna replace it by an str operand pump. I wish I could. Well, no, whatever. Yeah, I should have seen that coming. Training game. Help. So I got it to print. Okay, no, that's better. Oh, random. Yeah, I need random to have brackets. So see, yeah, that's the gotcha. Happens to the best of us. I think I've warned you about this a number of times when it happened to me again in one of those videos. Yes to the training game. Okay, let's try again. So we've got this problem here as well. But did I not fix it? Oh yeah, because this too, of course it appears twice. Okay. I could kind of make that into little helper functions. Avoid fixing it like 3 times when I get it wrong. But we're getting there. Help. Oh, we don't have user input in RPN. Whenever I use this user, oh, because I just copied it. I'm not even paying enough attention here. It was highlighted as well. So this is in the postfix expression. Thank you. And again. Well, that broke. Well, didn't do anything. Oh no, hold on. Hello. All right. So it's tried 8192, 15, all of that stuff. But it can't find any of those, yeah, because it's not, I mean, it's not 16. I guess that maybe I don't know about the minus. I feel like maybe I don't want to include the minus, because then like a bunch of those are negative, right? So let's be a bit smarter. So this is where I'm getting into heuristics. Random choice except minus. Okay, no, but there's a problem that I shouldn't penalize the user for not getting help, which I can probably do by. I can just put a continue on the thing. In fact, I don't even need to do this, and I'm just gonna make it continue to the next iteration, and then it will kind of like get all back display state, etc. Right. So at least I'm not kind of getting a point penalty for this, but not very happy with the efficacy of my, or effectiveness, or efficiency, all three really of my algorithm, because a lot of that stuff. So why don't we remove Where are they? Where are they? Where are they? Here. Okay, let's remove the minus for now. And then maybe even remove the divide, you know what? Like, and then I don't know about the divide, mind you, right? Okay, let's kind of like just so I'm surprised it's not written more it's not returned more decimal numbers for division, but 512, I don't know. Maybe it's kind of all of those ones or minus ones are just like a big roundup. Because did did this come back as an int? Oh no, we kind of yeah, like the evaluation like takes care of this as well, right? Can we expect integers? Right, so here let's try with those three, but when we get the extra one, we are going to be a random choice from operators plus a list made of minus. So just we add it back into the mix. So just you can get like this plus that or this times that. But is this going to be any better? To be honest, I doubt it. But I doubt it. Help. Okay, we still get some fair few negative ones. I think the divide is balking it. Do you know what? Ooh. I've messed up my operands big time. Oh, wait. Yes, I actually, those two things need to be in here as well. All right, so when I retry in the case of a, you know, I've tried this string already. I might, let me put a breakpoint here actually when in debug. Yeah, we're good. I don't need to see this one. Highlighted target is nothing. And then whatever we got. So operands, that one we get left. Operators, the tried expression get nothing. The initial expression at the moment is 8 plus 2. And it's not in tried, so we're going to skip straight over that. 5, 12. 8 times 2 times 2, 2 plus 8, 3 times 2. Yeah. Not finding any of those. It's pretty bad. I mean, I guess if I don't use divide, that would work better if I never done large. Okay. Again, but not the training game. So not the training game, anything else, but training game, and then go for help here. Yeah, sure, we can kind of see what we've gone on. Let's put a watch point on tried expression. So we just like particularly see it here. It's gonna be more convenient. 5 times 10, 1 plus 1 plus, or you can have a look there as well. 1 plus 10. And also let's put a watch expression on highlighted targets. It's very much empty, but and then at 5, length of what? No, we're fine. Oh, we have managed to have highlighted target 13. That's helpful. So it looks like if I remove the divide, this is playing nicer with. You can tell that these people at ZigZag are just having ideas and they never even tried their own things to see whether it was workable. Because they could have said like 60 attempts, right? Like this, it's a computer, right? Like we're not working on tight constraints. All right. But that did not work because I'm not seeing the. Okay, so. And it's tricky to reproduce as well because I know I had like number 13. I can't remember what the thing was, but. Okay, so I'm not going to print the result that we tried. I'm not going to print it here, but I'm going to print it if it's a valid one, so we can find out. Oh, I knew this was going to be annoyingly annoying. Really, didn't really expect that much. Okay, so we find 50. We found there's plenty of what. So we find it. We have a problem in my highlights as well, right? We returned highlighted targets, and we have continued. Okay, so let's have a little peek at my display targets, and yeah, put a breakpoint here. Run it again. Not a training game. Oops. Oh, yeah, of course, because now he's gonna display statement have been the okay. Help. Right, so it's find those 5, and here highlighted target is nothing. Okay, that's my problem, right? I'm coming into this, and the call stack, which I am in display targets, which is in display state, which was called with highlighted targets, numbers allowed. You can see the actual values there, right? Score. Highlighted target is what? What? Are we not? And then play game. Oh, but yeah, no, I can't be doing that, obviously, right? Because, yeah. Stupidly reset it when I thought I was being clever by calling the continue here. Okay, so I reckon that like after the display state, then it's probably an appropriate place to just, yeah, void it. Okay, and now, like really, I think like this time it's totally gonna work. The first time it displays, help. No, not here, obviously. More like here. Fine. And okay, highlighted target 7, 12. I get a whole bunch of them. This is looking good. And then, right, 7, I guess, 12, 19. How do I 19 from here? That's not, I mean, it's kind of does the thing. It's not a great one because it's not specified correctly. I think it should be very clear whether you want to have 5, whether we're talking about 5 like numbers in the target list or like just 5 different possible expression that would clear targets. But the general principle of the heuristic of this is like not very efficient. But then, I mean, if I do the solver, which really I don't want to after this one, frankly. I mean, I suppose there are ways you would trim that you wouldn't kind of start with things that are like are blatantly going to end up way too big or way too small, but that's only relevant when you get like a 512 in the list, because you know that that's such an unbalanced number compared to those that are between 0 and 100. Let's see, right, modify plugin, we did that. Suitable data structure, so we're using a list of the indices of the targets with display. That's the relatively easier part. Just to receive target suggestions. All right, let's a suitable expression that, yeah, this is the final challenge. Okay, 9 times 4 is like 36. It's 36. Okay. Need to do something, but most of them are going to be 2 things as well. The 19 must be a 3 then. The 19 is like 7 times 3 minus, no, I don't know what the 19 is, right? But let's try the 9 times, just to see it wipes them as well, right? 4. Okay, this is my breakpoint for the thing. My highlighted target is blank. That's important, right? Because then they're going to be, yeah, they're not there anymore. Cool. And if I say help, I'm going to get a different set. And now a whole bunch. 9. Well, 3 plus 5, right? And the 19 is still there. Okay, so I think we... Oh, what have I done here? Yeah, you threw in a... Yes, that's kind of like... That's considered an exception. Right, so that, I guess, is task ZigZag 11. it was as painful for me as it was for you. It's not the most exciting one, but well, let's have a look at the diffs so we can go over the changes we've done and the mistakes we've made and the friends we made along the way. But like what have we learned along the way? Like, don't mess up your types, obviously, right? Expecting strings and ints, and yeah, there's a bunch of debugging for like silly stuff. The place in which, so this is tricky, right? Because I know how to use the debugger and I would have kind of figured it out, but yeah, missing out like where you initialize a list. Anyway, so what we're doing here, the new bit is after we've displayed the state for this round, we make the highlighted targets blank, potentially maybe the first time we define it, and then we have the options to get help, in which case we'll just get the random suggestions that will define the highlight targets, and we continue, which is just gonna start the loop again, which means we don't go through here and I don't get subtracted the -1 score for everyone, right? And this time around, because the highlighted targets are going to be here, this is going to get displayed. The video about freezing targets explain this kind of principle well, right? If you wanna, like, if they do ask you to change something in the display of the target list, it's important to know that most of the time you're gonna need to have an explicit iterator as opposed to just doing a T in targets. And then instead of printing, we're building a list. And the new bit, which is how do you get that list of the indices of the targets, highlighted targets, based on targets and numbers allowed. And this is the brute force thing. So having really significantly simplified the problem by removing 2 of the operators, although I do add subtract back in if we get a third one, I'm happy with this. This hasn't broken. What you need to watch out for is if you're going to be trying things at random, it's important, especially if you're in a limited 30 at most, it's important you don't retry the same thing several times. So you want one of trial expression. And we've seen that I have gone at least once in trial expression because I'd run out of operands as I was popping. So sometimes you go into this. The way to do this is generate it the first time and then check if it's in the trial expression, but you can do this as a while, because if it's not, you will, if it is, sorry, you'll regenerate a new one. Regenerating a new one, because it relies on the random operands, means that you retake a fresh copy of the numbers allowed and you again shuffle it. The way I draw, again, shuffle, and then you pop them from the top, which makes sure you don't use the same number, the same item, right? The same number allowed more than once, even though it might actually be the same mathematical number. And then, so all of those steps to arrive to a new expression, a new infix expression we haven't tried. Then you convert it to RPN with the method we have now grown to love or loathe. And then you check its validity by checking is it in target, and then there's the index. So it does mean that if I had, say, more than 1.9 or more than 1.19, which I don't see here, right, but like I might be missing it. Ah yeah, see, look at that, 35 should have been highlighted. Well, I mean, they've not specified it, right? Like they, you know, I'm kind of doing the simpler one. If you want to be precious about it, if results in targets, so if you want to kind of do like highlight all of the available ones, you would do it. I'm not doing it from the diff, that's kind of ugly. So, no, this was the printing. Right, so now we know we have the result we just calculated that's in target list at least once. It might be once only. So I'm going to call it indices, and that's the empty list first. And then for this is, you want the iterator, right? In range of the length of targets. I put final G's at the end of like Python and lang. Well, length is more understandable than Python. Well, actually, no, I said, I see what I would have. Python targets plural. So heed the wiggly, right? Like the fact that I wasn't looking at the wiggly early on means that it cost me, you know, 1 running the code, 8 breaking, and my going back to the code. So on the exam, right, like use UID features for this. So all of the indices where the targets, the result appears in targets at the moment are blank, and then I'm iterating over the target list. And if targets at index I is equal to result, then you indices, you append to indices I, not the result, right? Because we want the indices as where they are in the target list. And we can probably comment on our print here. Right, and run that not in debug mode, so it'll be quicker. Boom. Help. Okay, I mean, no, it's not a training game, so it should be well, 10. Okay, you know, if you help. Well, at least it's not highlighting something that I would have missed, but that's an interesting one. 9 minus 2, yeah, 7 minus 2 minus 1. Help. I mean, okay, I'm just going to kind of keep lying until I encounter the problem, I guess. 6 times 7. Help. Okay, I'm not seeing a duplicate, that's the problem. If I had 31, if I had enough to do 31, 7 plus 7 minus 9. You're gonna have to take my word for it. This is where you can't get those in a real life situation, right? So with that was task 11, and that's not evidently not a realistic zigzag. Sorry, it is a realistic zigzag one, definitely, or weaker books even more, but like not a realistic AQA section D one. But it is kind of important that you, well, I mean, exploring a kind of possibility space and not backtracking, and, you know, kind of those solving games. You know, if you want to do an automated like Sudoku solver, whatever, this is, this is, you're getting bits into having to essentially explore the graph of the possible states of the game. But the general principle of like managing and wrangling like lists and knowing when to use the value, knowing when to use the index, knowing in particular, right, like you can't mess around the way I've picked my random operands. I need to make a copy, right? Otherwise you're going to be like damaging numbers allowed. I need to do a shuffle, and of course I need to do that every time I use them. So that's why that's the thing I'd forgotten there. I kind of like to oh, sorry, I'm highlighting from stuff you can't see. Yeah, right, kind of. Yeah, so we did learn some stuff, and but I wouldn't worry too much about a task of that type. So, well, I mean, I'm gonna be streaming next Sunday, and I hope every Sunday since I'm gonna start like actually scheduling them. But I do hope. So I'm not looking at the right camera now. I do want to have a look at the infix one, but I may not be doing it live because I might need a couple of passes and dry runs and just refresh myself on the conversions. The full solver, I gotta say, based on that, I'm not sure I've got the appetite, but you know, if I've ever get, you know, absolutely desperate for some content on the stream, yeah, let's just have another look real quick at what's in that. What have we got? What do we got? Okay, 12. Yeah, that's kind of more meaningful error messages, which was kind of, it was one of the first ones, but this one will tell you, particularly you need to keep track of how many it evaluates to. I think that's the only difference. The rest of the more meaningful error, like why was it not? We've kind of done this already in like 6, I think, or 5 or whatever. Yes, I like this one, the removing between 2 correctly identified. Just for fun, again, not necessarily for realism. Indices, I think I did that as a Wikibooks task, but yeah, that's kind of supporting the new operator, etc. This is the kind of save and load with a string of characters. Parentheses, yeah, all right, so that's the one I've recorded like 3 drafts video and couldn't get it in, although I did kind of start by explaining how would you use the stack and how does it manifest for the brackets, but there's just so many ways, like the parsing. Oh, okay, to be fair, like you can assume this will not only a valid number, but like, because, you know, if you close before you open, that's a valid number, right? Like it's not the valid matching of bracket. A lot of my, well, part of my struggle, in fact, I've got the first part video is like just the validation function. But even neglecting this, it's such a stinker because all of this stuff, like the meat of the, like conversion essentially, right? Because that's when the, it's like convert to RPN, I guess, right? to append, yeah, right. This passes the position back and forth to get number from user input. So the point is that like this is when you read digits, and then when you're outside, you read operands, because that's all the stuff you support. The moment you want to support something else, like the brackets, because support another operand, you're fine, right? Like you can have put your exponent, your caret over here, get the precedence right, you're sorted. That and the validation. But suddenly you kind of need to deal with brackets that are neither an operator nor an operand, although you expect to find them where you would find an operator, right? Because instead of having straight the plus, I'd close the bracket, but the closing bracket you expect to find where you find an operator. The opening bracket you expect to find where you would find an operand. After an opening bracket you find an operand, meaning potentially another opening bracket, right? After a closing bracket, you always find an operator, or of course another closing bracket, right? So like if you look at it's a parsing tree, because it's a finite state machine of like, where's my position head and what am I reading? And then you put yourself in a different sense, like read opening brackets, and then you get a number, you get another opening bracket, you kind of keep track of how many you get open. Fine, but I will not do this live, because like I've humiliated myself in private a number of times trying to do the bloody, ruddy, extremely frustrating brackets. I might cut some bloopers because I can't be bothered, but yeah. Okay, well, stay tuned again every Sunday from now on, because there's only, like 1, 2, well, it's today. Okay, so this is today, right? So the next one is like 1, 2, 3, 4 Sundays to 4 Sundays to paper 1. Stay strong, keep coding. Don't neglect obviously the rest of the computer science specification, or indeed your other subject. Until